All right, going to be doing the homework here for 7.4, trigonometric functions of any angle. All right, so a point on the terminal side of an angle theta is in standard position is given to you. Negative 724 is the point. Find the exact value of all six trig functions. So what we have here is a point here. You go to left 7, you go up 24. You've got this point here. So there's two ways of going about this. You could draw your right triangle like this. And then you could figure out that this side here is -7, and then this side here is 24, and then go find the hypotenuse. I'm going to go ahead and do that for this problem, and maybe on the next one I'll do it the other way. They're very similar, but slightly different. All right, so here we go. I'm finding the hypotenuse, so I'm going to call it h squared. So I'm going to try and figure out what h is. So I'll need my calculator perhaps, or if these numbers start getting weird, 24 squared plus, well, I'll just write it down. We've got 576 plus 49 equals h squared. And so when I do that, I get 625. And that happens to be a perfect square. So good. This is going to be 25 as h. And we're going to always have h be positive. So we want to look at this as being this side here is the opposite side. This side is the adjacent side. And this side here is the hypotenuse, which is 25. And now we just figure out all the trig values. So sine is opposite over hypotenuse. So this should be 24 over 25. Okay, cosine should be adjacent, which is -7 over hypotenuse. And tangent should be opposite over adjacent, so 24 over -7. All right, then we just do the reciprocals. So 25 over -7 would be cosecant. Oh, did I do that? Oops, I did the wrong one. 25 over 24, sorry. I was looking at cosine. Okay, and now the 25 over -7. And then the reciprocal of tangent. Tangent is this, so we just flip it over, -7 over 24. All right, all right, so this is another problem, same sort of idea here, but I'm gonna do this slightly different. I'm gonna go out 4, go down 2, and I'm gonna look at this as a point. This is the point 4, -2. And so what we need to find is this radius. And so you go about the same way, 4 squared plus -2 squared equals r squared. And so you get 16 plus 4 equals r squared. So 20 equals r squared. So root 20 is r. And now we just use the fact that we know what x is. X is 4. We know y is -2. We know r is root 20. And then we use the definitions of the trig functions. So sine will always be the y coordinate, -2 divided by the r, the radius. We covered that in class. Uh-oh. Hold on. Or y over the radius. Oh, okay, they're going to want me to simplify the radical. Oh, I almost forgot. This is equal to, let's see, square root of 4 times 5, which is 2 root 5. Okay, let me do that then. So on the bottom here, I'm going to put 2 square root of 5. Do they want me to reduce that? The 2, that's a 1. Okay, so they wanted me to reduce the fraction. Wonderful. Okay, cosine will be the y coordinate over the r, so the x coordinate over this, so 4 over that. Let me write that down. So it'll be 4 over 2 root 5, and then 2 goes in here once, 2 goes in here twice. So we should get 2 over root 5. And tangent will just be the y over the x, so -2 over 4. That reduces to become -1/2. All right. Now, cosecant, I'm just going to flip these over. So cosecant is reciprocal of sine, so negative √5/1. So I'm just going to put negative √5. And then the reciprocal of cosine is √5/2. And then tangent, let's see, we had negative 1/2. So we're going to flip that over. It's going to give us -2. All right, this problem is almost exactly the same. I really don't know if I want to go through every single one of these 32 problems. This is going to be -4, -2. So that's your point, -4, -2. And so if you go through and find the radius, you'll find that the radius is the square root of 20 again, which is really 2√5. And so you know that x is -4, y is -2, and the radius is 2√5. And then you just go through and do all your trig functions off of those. So I'm going to go ahead and just leave that and move to the next problem. Okay, so use coterminal angle to find the exact value of the following expression. So for this, do kind of what we did last class. I'm looking at 420 degrees. And if I subtract 360 from that, then I get 60 degrees. So I'm at 60 degrees, which is up here. And I want sine. So this is 1/2 √3/2. So sine is the y coordinate. Oh, wait a minute. Oh, they just want to know a coterminal angle. Oh, okay. Sorry. That's it. Okay, now they want to know what sine is. All right, so now that's going to be square root of 3/2. Oh, I forgot the division. Divided by. I'm messing that up. Come on. 2. Get rid of that. Okay, so same thing. Negative 690 degrees. So what I'm going to do, since this is a negative angle, I'm going to add 360. So if I take negative 690, I'm going to add 360 to it, I get negative 330. And I'm going to add 360 again. And you can always add multiples, full rotations, and get to a coterminal angle. So I'm going to add 360 to that, I get 30 degrees. So 30 degrees would be a coterminal angle. And then I want cosecant of that. So we're at 30 degrees. 30 degrees is here, and that's going to be √3/2, 1/2. And since we're looking for cosecant, we're looking for the reciprocal of sine. So reciprocal of the y coordinate, we should just have 2. All right. So for this one, same story here. Take a negative 11 pi/3. Let me add a full revolution, 2 pi. So we're in radians, so I have to use pi here. And get a common denominator, 6 pi/3, and then go ahead and add those. And when I do, I get negative 5 pi/3. Let me do it again. Let me add a full revolution again, 6 pi/3, and I'm just going to get pi/3. So pi/3 would be a coterminal angle, and that's here, and that's 1/2 √3/2. So coterminal angle is pi/3. And cosine of that would be the x coordinate, so it's 1/2. All right, this one should be easier. We have tangent of negative 5 pi. So I'm just going to count by 5s, and I'm going to count negative angles. So here's pi, 2 pi, 3 pi, 4 pi, 5 pi. So I'm right here. This is the point -1, 0. Tangent is the y coordinate. So a coterminal angle, let's do that. Coterminal angle. So this angle right here, we can look at that angle as being pi, right? That's just there. So I'm just going to use pi here. And then we have that tangent is the y over the x. So 0 divided by -1 is just 0. All right. So now name the quadrant in which the angle lies. So they tell us that sine has to be greater than 0. Now sine is always your y coordinate. So that means your y coordinate has to be greater than 0. So we can't be down here. And then cosine has to be less than 0. Now cosine is always your x coordinate. And to be less than 0 means that we have to be to the left of the y-axis. So we can't be over here. And that means we have to be here. So we have to be in the second quadrant. Okay. We'll do one more of these. Okay, here sine has to be less than 0. So sine has to be negative, right? So the y has to be negative, means we can't be up here. And then tangent has to be negative. So for this, I think what I'll do is I'll remember all students take calculus. So the two places that tangent is positive is here and here, but we need tangent to be negative. So that means we cannot be here and we cannot be here, which means we have to be here. And so we have the fourth quadrant. Just a second. All right, so here we're trying to find the reference angle for the angle -45 degrees. So here we have -45, that's going to rotate clockwise to here, that's -45. But the reference angle will be, this angle here is a positive number, so that would just be 45 degrees. So that's pretty, it's almost so simple that it's easy. So I'm gonna go 45 degrees, there we go. Maybe the next one will be more interesting. Here we go, 155. So let's figure out where we are. So 155, remember all the way over here is 180. So we've got to be like somewhere over here. And that means that this angle here is 155. And that means we're looking for this angle here. And so that should be 25 degrees. So that's just, we need both of these to add up to be 180. So got to be 25 here. That's it. Reference angle for 325. So 360 is all the way around. 325 should be somewhere around here. 325. So I'm looking for this angle. So what would I need to get all the way to 360? So I'd have to add 35 degrees to that. And that would get me to 360. So that would be 35. Now we do the same thing with radians. So 9 pi over 8. This is a little bit tricky, all right? So we got to figure out where is 9 pi over 8. So I would like for you to look at 9 over 8. That 9 over 8 is a little bit bigger than 1. So that means that this is a little bit bigger than just 1 pi. Now 1 pi would be here, that's just pi. We're a little bit bigger than that. So the angle we're looking at is somewhere like here. Okay, that's our 9 pi over 8. So what we want to do is figure out what this angle is right there. So what we need to do is take 9 pi over 8 and subtract from it the blue, which is the pi, and that should give us this little black angle here. So I need a common denominator, so I multiply top and bottom of that pi by 8. And then we just get 9 pi minus 8 pi is 1 pi, so pi over 8 should be our reference angle. Pi over 8. I hope there's another one of those. Okay, good. Okay, so let's try this. 6 pi over 7. So we have 6 pi over 7. So this number right here, 6 divided by 7, is a little bit smaller than 1. So that means this is actually smaller than pi. So that means that the angle we're looking at there doesn't quite get to pi. It stops right about there. That's the angle 6 pi over 7. We're trying to find this angle right there. So what we're going to do is we're asking ourselves, if we take 6 pi over 7, what do we add to it to get pi, right? So what do we need to add to this to get pi, to get this half rotation? So if I look at it that way, I can subtract 6 pi over 7 from both sides of this equation. And then that basically means I'm solving for the question mark. So I really just need to take pi, subtract 6 pi over 7. I'll get a common denominator, so I multiply top and bottom of this by 7. And then when I subtract, I just get pi over 7. 7 pi minus 6 pi is 1 pi, so pi over 7. Pi divided by 7. There we go. So it's important to be looking at the number in front here. Here's another example, negative 5 pi over 4. So if I look at this, negative 5 over 4 is a little bit, well, 5 over 4 is a little bit bigger than 1. It's negative, which means we're rotating clockwise. So this is going to be a little bit past pi. So it looks like this. We're going to rotate clockwise. We go a little bit past pi and get to here, like right there, somewhere in there. And that's going to be negative 5 pi over 4. So what we want to know is this angle here, right? That. So I'm trying to think of different ways you could do this. What we need is that when you take this negative 5 pi over 4, okay, and you add to it some angle, you should get pi. So let's, well, actually, you know what? I think there's a better way to do this. Let's do this. Let's go about this a slightly different way. Just, I think, to make it easier. We know that the pi over 4s land on these. Like that, right? Those are our pi over 4s. So negative 5 pi over 4 took us, one, oh, let me count those. It's 1, 2, 3, 4, 5. So we're here, right? That is the same as going 1, 2, 3. That's the same as 3 pi over 4. So what we're looking for is this angle here, which would just be pi over 4, right? That's what we need to get up to this angle. I'd need pi over 4 here. That would be my reference down to the x-axis. So I just go pi over 4. I think that's a cleaner way of doing that problem. All right, I think you can do this. Reference angle of 605, just subtract 360 from that, and then figure out where you are, and then figure out the distance to the x-axis. So I'm not going to do that one. I don't think I'm going to do that one either. Okay, so let's do this one. So use the reference angle to find the exact value of this cosine of 480. Okay, so first let's talk about 480. Let's find a reference angle. So I'm going to subtract 360 from that. And when I do that, I get, what's that? 120 degrees. Okay, so let's figure out where 120 is. Well, this is 60 degrees, right? If we add another 60, we'll be at 120. So that's where 120 is. And that has the coordinates for that point, negative 1/2 root 3 over 2. And so if we look at cosine, it should just be the x coordinate here, right? So we should just get negative 1/2. That's it. Now, you know what? Let me go back. They wanted us to use the reference angle. I kind of cheated. I did it in a different way. So the reference angle, sorry, the reference angle, that was 120. The reference angle here would be 60 degrees. So the way they want us to do this is they say, okay, instead of doing cosine of 480, we're going to look at cosine of 60 degrees. And we know that 60 degrees is here. Cosine is the x coordinate, which is 1/2. So we know that this is 1/2. However, because we are in the second quadrant and all students take calculus, we know that the only thing that's positive here is sine. So for 480 degrees, right, which is really this 120, that our answer must be negative. So we would take this answer and make it negative, which gives us -1/2. Okay, so it's a different way of doing it. You can see there's multiple ways to do these problems, and that's what can make things a little bit tricky, but we should all arrive at the same answer. Okay, let's do this one. Reference angle, -315 degrees. So -315. So -315 takes us over here. It's almost -360. So we would need to go another 45 degrees here. So that's going to be 45. Right, this -315. So a reference angle would be -45 degrees. And so what we're going to look at is cosine of 45 degrees. And that's the x coordinate there, which is √2/2. You should know that by now. And then we're going to think about all students take calculus. But wait a minute, we're in the first quadrant, so all the trig functions are positive. So this should just be √2/2. Okay. Cosecant of 390. Again, we're going to use reference angle. So 390, we're going to go, here's 360. And then we have to go another 30 degrees. That'll be our reference angle, 30 degrees. So we want to know what cosecant of 30 degrees is. The point here is √3/2, 1/2. Cosecant is the reciprocal of sine. Sine is the y coordinate. So this should just be 2. And also we are in the first quadrant. All students take calculus. So all the trig functions should be positive there. So we should get 2. Let's do this one. Cotangent of 330. So 330 is right around here. And that means our reference angle is another 30 degrees that would take us to 360, right? So yeah, if this is 330, then we would need another 30 to get to 360. So our reference is 30. And so we want cotangent of 30 degrees. And at drawing this, our 30 degrees here, cotangent, so we have √3/2, 1/2. Cotangent is the x over the y, not the y/x. So this is √3/2 times 2/1, just doing multiplication of the reciprocal, and we just get √3. So our answer so far is √3, but we're doing all students take calculus. And in the fourth quadrant, which is where this angle 330 lies, the only thing that's positive is cosine, and we're looking at cotangent. And that means tangent is negative over here, and that means the reciprocal cotangent should be negative. So it should be this answer, √3, but negative. So negative √3. All right. Use a reference angle, clear. All right, 7π/3. Let's figure out where we are. All right, so I'm going to count by π/3s. So here's π/3, 2π/3, 3π/3, 4π/3, 5π/3, 6π/3, 7π/3. So that's where we are. But that reference angle there is just π/3 then. And so that point there is 1/2 √3/2. We're looking for sine, which is the y coordinate. And in the first quadrant, all trig functions are positive. So this should just be √3/2, just the y coordinate. All right. -π/4, we're looking for cosine of that. So -π/4 goes here. And so the reference angle here is π/4. And so we're looking at cosine of π/4. And cosine should just be √2/2. But we are in the fourth quadrant. And so in the fourth quadrant, cosine is negative. I'm sorry, cosine is positive. So it's just going to be this answer, and we're going to leave it positive. √2. Right. Tangent of 19π/4. I'm going to count by pi over 4s. Here's pi over 4, 2 pi over 4, 3, 4, 5, 6, 7, 8, 9. We're in the first quadrant. And since we're in the first quadrant, everything's going to stay positive. So I'm going to be taking, I'm really looking at pi over 4 as my reference angle. And tangent is just the y over the x, and we're just going to get 1. Whoa. Did I not count that right? Did I do 9 pi over 4, not 19? I think I did 9. 1, let me do it again. I'll do it in blue. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oops, we're over here. Okay, so our reference angle is still pi over 4 here. And when we look at cosine of pi over 4, or sorry, tangent of pi over 4, the x and y coordinates are the same here. So we should get 1. However, because all students take calculus, we're actually in the second quadrant. So sine is the only one that's positive there, and we're looking at tangent. So we should actually get a negative here. Sorry, I just counted 9 instead of 19. There we go. Okay, sine of pi over 8. Or sorry, sine of 8 pi. I'm just going to count this out. This is going to be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. So we're here. This is 1, 0. And so sine is just the y coordinate. So this should just be 0. All right, let's do this one. We've got secant of negative 4 pi. So that's negative 2 pi. That's negative 4 pi. So we're here at 1, 0. Secant is the reciprocal of cosine. Now, cosine is the x coordinate. So the reciprocal of 1 is just 1. All right, here we go. That's more interesting. Find the exact value of each of the remaining trig functions. They tell us that sine of theta is 24 over 25. So what we're looking at here, sine of theta is 24 over 25, and we're in the second quadrant. So we're in Q2. So let's take a look at that. We're in Q2, so we're not here, we're not here, we're not here. Sine is, remember, is opposite over hypotenuse. So I'm going to draw a triangle here, like this. And I know the opposite side must be 24 and the hypotenuse must be 25. So I need to figure out what this side is so that I can get the adjacent, right? So I'm going to call that A. So I know that A squared plus 24 squared must equal 25 squared. And I'll do that math on my calculator. I'm going to do 25 squared, and I'm going to subtract 24 squared. I get 49. Yeah, so A squared is 49. So A must be plus or minus 7. We take the square root. Now, because we have moved to the left, this A must be the negative 7. That's very important because we're in the second quadrant. And now we know adjacent, opposite, and hypotenuse. So now we should just be able to figure out everything. Cosine should be the adjacent, negative 7, over the hypotenuse, 25. Tangent should be the y coordinate, which is just 24, divided by the x coordinate, which is negative 7. And then now it's just all reciprocals. Cotangent, they want cotangent now, so negative 7 over 24. That's weird. They asked us that in a different order. Reciprocal of cosine, 25 over negative 7. And cosecant reciprocal of sine, just flip sine over 25 over 24. I like that question. All right, another good question I like. What is the, let's see, find the exact value. Okay, so they're telling us that we're between 90 and 180 degrees, so we're not down here. Oh, no, I just messed that up. Okay, we are between 90 and 180, so we can't be between 0 and 90, can't be after 180, so we're in the second quadrant. And it tells that cosine of theta is -5/6. So cosine is adjacent over hypotenuse. And remember, the hypotenuse will always look at being positive. So we're going to make that 6 be positive and the negative go with the 5. And I'm going to draw a triangle like this. 6 is the hypotenuse, and -5 should be the adjacent, which is this side. And now I need to figure out what this side is. I'm going to call it b. So -5 squared plus b squared must be equal to 6 squared. So 25 plus b squared equals 36. If I subtract, you get b squared equals 11. So b is √11. And it will be positive. It's either plus or minus, but because we're going up here, that'll be a positive number. So now let's fill everything in. Sine is the opposite, which is √11. We just found that that's opposite. So square root 11 over 6. Tangent is the y, which is √11 over the x, which is -5. So square root of 11 over -5. Cotangent is just that flipped over. Secant is just cosine flipped over, but they gave us cosine, so that's going to be easy, -6/5. And cosecant is just sine flipped over, so 6 over square root of 11. There we go. All right, so secant theta is 6 and tangent is positive. So all students take calculus. So if tangent's positive, it's got to happen either in the first or third quadrant. So we can't be here, can't be here. And now secant is the reciprocal of cosine. And remember, cosine is the x coordinate. So this is saying secant of theta being 6 means that cosine of theta has to be the reciprocal, but this is a positive number. And since that's the x coordinate, means that we have to move this way. And that means we cannot be in this quadrant. So we have to be in the first quadrant. Okay, so let's stick with this cosine is this right here. That is adjacent over the hypotenuse. So I'm gonna draw a triangle. I know my adjacent side is 1 and this is 6. So I need to figure out that side. I'll call it b. So we get b squared equals 36 minus 1 is 35. And then we have b is plus or minus √35. But I'm going to take the positive because we're going up here. So b is √35. That's our opposite. So we want to know sine, it's going to be the opposite, √35 divided by, √35 divided by the hypotenuse 6. Cosine is going to be, well, we knew that was just the reciprocal of secant, so 1/6. Tangent is the y value, which is square root of 35, divided by the x value, which is 1. Didn't take it, it wants me to simplify that. Square root of 35. Okay, cotangent is 1 over that, flipping over the tangent. And cosecant, just flip over sine, so 6 over square root of 35. All right. I like these. Okay, tangent has to be 3/4. So remember, all students take calculus. So we can't be here and we can't be here because tangent has to be positive. That can happen in the first or third quadrants. But then they're telling us that sine has to be negative, right? Sine is the y coordinate. So we can't be here because our y coordinate is positive in the first quadrant. So we've got to be in this quadrant. Now, tangent of theta being 3/4, this is tricky. This is our opposite over adjacent. But wait a minute, if we draw a triangle like this, our opposite side can't be +3, and our adjacent can't be positive because we have to go down and we have to go left. That means they both have to be negative. So this is actually -3 and -4. But see, when you do tangent and do -3 divided by -4, you get +3/4. So they've cleared out the negative. So it's tricky. It makes you think that they weren't negative, but in fact, they have to be because we're in the third quadrant. So this is what it looks like. And then we can get the hypotenuse. We can do -3 squared plus -4 squared equals the hypotenuse squared. And you'll get 5 for the hypotenuse. Remember, the hypotenuse is always going to be a positive number. So that should be it. We should be able to do this. So sine will be opposite, which is -3 over the hypotenuse. Then we have adjacent, which is -4 over the hypotenuse. Cosecant is just sine flipped, so 5 over -3. Secant is just cosine flipped over, so -5 over 4. And cotangent is just tangent flipped over, which is 4 over 3. All right, I think I've done enough of those. And that one I did in class. So I think I can say I'm done. Hope that helps.